clearly heard. If you are tuned into our social media accounts, please state your nickname, department, and your question. Do not spam the chat box. Always be courteous and do not engage in a chat with others while the webinar is ongoing. The organizers reserve their right to disengage anyone who will not follow the guidelines. We are now ready to start our event. Please stand by for the Philippine National Anthem, followed by the FEU Multi-Faith Prayer.
Day to each and everyone who is gracing our today's webinar. I am Al Otaide Advincula and I will be your moderator in this presentation. So we would like to thank those who made this possible, especially Sir Richard Lim, or Richmond Lim, Sir Evasco, and the Education Technology Office. So good afternoon to all FEU faculty members and students who are joining us today. We also appreciate our participants from outside the FEU community. We hope to satisfy your expectations in this presentation. So to the Dean's Office, led by our hardworking Dean, Dr. Rowena Capulong Reyes, and Associate Deans Sir Mark Isla and Sir John Yason, thank you for your endless support and untiring effort. Of course, to the Mathematics Department, led by our Chair, Sir Genesis John Borja, thank you very much, Sir Jen, and good afternoon. Microsoft Excel is a spreadsheet developed by Microsoft that has been used by countless students and professionals, and non-professionals as well, around the world for various purposes. Although we all know such free program is indeed a helpful tool to many of our needs, from a simple personal scheduling or listing of expenses to organization of school or work records, it can serve as a powerful instrument in doing statistical research. So to formally commence our program, I am pleased to call on Mr. Genesis John Borja, our Chair of the Department of Mathematics, Institute of Arts and Sciences, to convey his opening remarks.
Hi, thank you, Sir Al. To our Far Eastern University officials, to the Institute of Arts and Sciences Dean, Dr. Rowena Capulong Reyes, our Associate Deans, Sir Mark Isla and Sir John Yason, to our fellow educators, to our dear students, guests, and participants, a pleasant afternoon. It is my pleasure to welcome you all in this session of our mathematics webinar series under the IAS base program, or the Virtual Activity Supporting Education. For this session, our theme is on data analytics using a platform that we are all familiar with, that is MS Excel. Our speaker, our very own Ms. Issacar Bernaldez, will give us an overview and a quick tutorial on how to maximize our use of MS Excel in terms of data analysis, a topic of such relevance not only for our students, but also for our fellow educators doing their respective research indeed thrills me. This webinar shall help our participants conducting research to identify tools in MS Excel which can be utilized to test and verify their data. Aside from these, the pandemic more than ever made us realize the importance of mathematics and statistics and their applications to data analytics and information technology. Indeed, having the appropriate knowledge and skills in these fields now really empowers us in our endeavors in our own respective fields of specialization. With that in mind, the Department of Mathematics of the Far Eastern University has been offering our Bachelor of Science in Applied Mathematics with tracks in data science and information technology. Just a side note, our program recently underwent and successfully passed the elusive ASEAN University Network Quality Assurance or the AUNQA accreditation. Just please let me thank everyone and take this opportunity to thank everyone who made such a success possible. So I will not prolong this anymore since I know that we are all excited to proceed with this event. Please let me end by thanking our organizers, our guests, and participants for joining us today. We hope that you enjoyed the rest of this activity and actively participate in the future programs of our department. Thank you, and again, good afternoon.
Thank you, Sir Genesis. We are reminding our participants to type in your questions in the chat box that are to be addressed by our speaker. So to introduce us, the speaker for this event, we call on Ma'am Mary Joyce Hernal, our assiduous colleague in the mathematics department.
Thank you, Sir Al. So a pleasant day to everyone. I am honored to join you this afternoon and be endowed the opportunity to introduce our guest speaker. Our speaker is our very own academic staff from the Institute of Arts and Sciences, Department of Mathematics. She is one of the persevering and dedicated individuals in our roster, handling statistics and physics courses. An admirable lady, our presenter is the perfect combination of beauty and brains. She is a graduate of BS Applied Physics at the University of the Philippines, Los Baños. She earned her master's degree in industrial engineering from the University of the Philippines, Diliman. Currently, she is pursuing her doctorate degree in Ateneo de Manila University. Research and data analysis are some of the many strengths of our esteemed presenter. While in UPLB, she studied the effects of temperature on bismuth 2212 formation on crystals. She also worked as a researcher under UP Diliman Marine Science Institute Physical Oceanography Laboratory, where she studied sardines living in the seas within the vicinity of Mawalbawal, Cebu, Philippines. Our speaker had also worked as a researcher and consultant in collaboration projects of the UP Diliman Industrial Engineering and Operational Research Department and the Department of Science and Technology while working on her master's degree. At present, she is working on patient research together with her FEU colleagues. With all her accomplishments and talents, an admirable facet of our speaker is her genuine humility. So without further ado, please join me in welcoming our speaker, Ms. Isacar Bernaldez.
Hello, good afternoon to all of us. So today I'll be discussing a really good topic. This is a tutorial on how to maximize your Excel, MS Excel tool. At least itong tool na to, libre siya sa atin. It's free for FEU faculties and FEU students, and we're already familiar with the tool. So I will share my PowerPoint presentation. So my talk today is about data analysis using MX Excel. And this will be my outline. First, we will talk about the basic cleaning of data. This is not really all of it. It's just the basic way of cleaning your data. The next one is how to get descriptive statistics. Now, descriptive statistics is just measure of central tendency, measure of dispersion, measure of position, and all those basic type of statistics. But remember, these are just descriptive statistics. We don't make decision yet with this data. The next one is sometimes our data needs some cleaning when it comes to outliers. That's possible. May mga sagot na more than sa ina-expect mong normal sagot. So there will be what we call outliers. I will be using quartiles in getting outliers, but there are other tools to get outliers. But for this event, I'll just use the quartile, the interquartile range. The next one is we'll go to a higher level of statistics, and that is inferential statistics. We will be talking about correlation, the use of correlation, and how to do it in Excel, the use of t-test and z-test, their difference, and how to use it in Excel. And the last one will be how to use ANOVA, and what is the use of ANOVA in Excel. So first, let's talk about cleaning of data. So I have here a video. I will play it. I will just check its volume. Please tell me if the volume is too low. I will use my own laptop speaker if it doesn't really work. So I'll play it now.
So what if we have the following data? We have capital letters, multiple spaces, not a formal type of data. What we can do is we can use Excel to make it more proper for us. So we will use the formula proper. As you can see, that will be a first capital letter. And then you double click this green bar and we have this. So all of them are in capital letters. The first letter of the word will be capitalized. But what if we want to take off all those unnecessary spaces? So to do that, we will use the word trim. And then, close parenthesis, we enter it. It's not obvious in the first cell, but let's double click the green cell here. And then we have a more and a trimmed version of our old data. Let's hide this one. Let's do the same thing on the segment part. So let's insert a column, write the word proper, parentheses, the word trim, parentheses, and the cell that we want to trim and proper. So we select enter, click the green box, and we have now a proper and a trim version of our data. But what if we want a uppercase? So all capitalized letters. So we use the word upper. To copy that, double click the green box, and we now have all capitalized letters. Now what if we want all lowercase? So to do that, let's click lower, write the word lower, and then enter. So double click this box again, the green box, and we have now all lowercase. So what about currency? So we click here in the general part, we'll select currency. But I have peso here, so we change it by clicking the money part here and we select dollars. And that's how we write in currency values. What if you have blank spaces? What you can do is go to special, select blanks, and then it will highlight the blank parts. If you want to write the word missing, so let's write the word missing, press Control Enter or Command Enter. So we have now all blanks with missing. Now what if you want to replace a word? You can go to the word replace, find what word. Let's say I will replace the word missing replace it with not applicable. And then after that, I'll just click replace all. I have two replaced and then close. And that is the basic way of cleaning data.
So ayan, I think my audio is not that good. Maybe in the next video, I will use my speaker to give the audio of this video. So this is what we call cleaning the data. Not pag nakuha mo yung data, please remember, pag nakuha mo yung data, hindi lahat naka-capital letters. Sometimes, especially when it comes to numbers, sometimes blanco siya. Sometimes, hindi talaga siya proper na data. So how to deal with that? This is how we clean data. For not applicable, as you can see the word not applicable, in statistics, minsan, pinapalitan natin siya ng average. If there is missing data, ang nilalagay natin ng average, pero note natin yan. Like we know that for the missing data, we just use the average, especially if those data are very important for the analysis. And we will normally compute the one with the temporary data, like the average data, and the data na hindi natin nilagyan ng average. Then kino-compare natin kung mag-iiba ba talaga sila. So, yeah. Ayan. So, yeah, so let's go to the next one. So this is how we clean data. So ayan. Now, excellent na yung audio. I think because my audio came from my microphone and unlike dito, galing siya sa mismong file. So, I'll try to fix it later. Okay, now let's go to descriptive data. So for descriptive data, this is very simple. It means describe. So when we say describe, we don't want naman na we make conclusion na agad. We can if you want to, but not the one with probability involved. Now, descriptive statistics consists of methods in organizing, displaying, describing by using tables, graphs, and summary measures. Now, the first one is what we call the measure of central tendency. The measure of central tendency, you're familiar with this. We have the mean, the median, and the mode. The common one, mean means to say average, median, yung gitna, mode is the most frequent number na lalabas. So it depends on the purpose. Like for example, if we're talking about your grades, sabi mo sa nanay mo, ma'am, my grade is in mathematics, I got 87, in science, I got 88, in Filipino, I got 97. Then your mom told you, anak, gusto ko lang ng isang number. One number that will summarize your performance. Normally, we get the average. We don't get the center, the median. We use the average to summarize values, especially if there's a lot of it. The next one is median. Sometimes ito yung definition natin ng sulit, right? Ayaw mong bumili ng mahal, ayaw mong bumili ng mura, so you go for the center. We normally call this the median, the center value. We don't average them, we just look at the values and whoever yung nasa gitna will be the median. The next one is the mode. Mode is usually used if we have categorical data, sometimes quantitative data too. So mode is the most frequent number na lalabas. The next one is the measure of dispersion. This is something na hindi masyadong common. Hindi masyadong nare-remember ng mga estudyante. Yung purpose mismo ng measure of dispersion. From the word dispersion, it actually means how far they are from each other. Now, let's say may isang exam. Sa exam na to, ang mga grades ng estudyante ay 56, 57, mga 52. Ayan. Tapos sa isa namang exam, ang grades ng mga estudyante is 87, 52, and 13. Now, I have here A and B. You will actually observe that B is more dispersed. So the measure of dispersion, compute the dispersion, kung gaano sila kalayo sa isa't isa. So when you compute range, that means they are far from each other. The higher the value, the more dispersed the data. Variance, if you compute for the variance, the higher the value, the more dispersed yung data. Kung mas maliit yung value, ibig sabihin, mas malapit yung data sa isa't isa. The standard deviation, this is the most common measure of dispersion computed. Di ba ito? Sa measure of central tendency, it's the average. For the measure of dispersion, it's the standard deviation. Kung mas mababa yung nakuha mong value, ibig sabihin malapit sila sa isa't isa. But if mataas yung nakuha mong value, malayo sila sa isa't isa. And that's why standard deviation is more associated sometimes, most of the time pala, siya ay ginagamit to compute errors. So if to know if your data is reliable, we check the standard deviation. If the data is far from each other, maybe you have to repeat the study. But if the data is near to each other, then, especially trial 1, trial 2, trial 3, then you have less errors. So that's why these two measures, descriptive statistic measures, are very important. Hindi ka lang nagsa-summarize kung ano yung summarized value, the measure of the central tendency. Inaalam mo din kung gaano kalayo yung data sa isa't isa. Now, let's compute that using Excel. So how do we use Excel? I will give you the first one, the basic one, and the second one using the data analysis tool. So I'll go now to the next slide. So here in Excel, we have here equal average to get the mean, equal median, equal mode, dot multi, because sometimes you will have multi-modes. We have the range, S bar, bar dot S for variance, standard dev dot S for standard deviation. For coefficient of variation, you divide the mean and the standard deviation. And we have here the quartile, the percentile. And if you use these functions in Excel, you will have this value. And I will show you in this problem. So let's have a simple problem here. Suppose that the average waiting time for a patient at a physician's office is just over 29 minutes. To address the issue of long patient wait times, some physician offices are using wait tracking system to notify patients of expected wait times. Patients can adjust their arrival time based on this information and spend less in waiting rooms. The following data show wait times in minutes for a sample of patients at offices that do not have wait tracking system, and wait times for a sample of patients at offices with such systems. I hope you're familiar with this. When we say wait time, I'll think of an example. Nag-iisip ako, but I know I experienced this one. Yung tipong pupunta ka sa isang office, tapos sasabihin nila na ang waiting time dito ay 30 minutes. So what if plano mong pumunta ng bangko? Then sabi ng bangko, oy, marami kaming customer ngayon. Ang waiting time namin is 1 hour before yung isang person. May mga like for example sa deliveries. Di ba sa deliveries, sabihin nila sa inyo, ang waiting time mo before mo tatanggap yung Grab delivery mo ay mga 30 minutes. So we call that a waiting time system. So here we have patients. They go for checkups, and then may mga patient na pupunta na lang sa office, pupunta na lang sa physician's office. Meron namang mga patient na bibigyan sila ng information about their time. Like, sasabihin sa kanila na, uy, pupunta ka ngayon sa physician's office, may 30 time wait. So this is the one that they're trying to compare. And then, ang tanong dito, may effect ba talaga kung sasabihin sa'yo na may 30 time wait? Or okay lang na pumunta ka doon at maghintay ka? Alamin mo na lang kung ilang minuto ka maghihintay. So these are the data that we have. Now we will use descriptive statistics to compute for their mean, median, mode, and their measure of central tendency, the measure of dispersion, and the measure of position. So let's have this video. I will use my computer audio, so I'll just check. I will just change the settings.
So let's get the descriptive statistics of the following data. Let's start with without wait tracking system. Let's get the mean or the average. So we write equal the word average. We select the values that you want to average, or you can just select the whole column. So AA, that is the average. The median equal the word median. Select the whole column, and then we have that answer. The mode, we can highlight 2 cells because sometimes we have multimodal. So we select mode multi. and then select the column, then Control Enter. It says NA because there's no mode. So let's just use the word none. The range is the maximum, get the maximum of column A, parenthesis, minus the minimum of the same column, and close parenthesis again. And then enter. For the variance, so in this sample, this is a sample variance. So use var.s. var.p is for population. So we select the column again, and we now have a variance. The standard deviation, stdev, we select S, P for population, S for sample. Since we have a sample, we have that. And then the coefficient of variation. The coefficient of variation is the standard deviation divided by the mean. So that is the coefficient of variation. They vary in this certain value. The next one is getting the position, the percentile. So we select percentile.xe, select the array, so all in column A again, and 0.85 because we're looking for the 85th percentile. Close parenthesis, then enter. Now let's talk about quartile. This is another measure of position. So quartile, use the quartile.xe, select the array, quartile 1 for quartile 25th percentile or quartile 1, select 1, close parenthesis, enter. Quartile 2, quartile.xe again, select the array, and number 2 for quartile 2, enter. Quartile 3, quartile.xe, column A, and number 3 for third quartile, close parenthesis, enter. The interquartile range, or the IQR, is the subtraction or the difference between the third quartile minus the first quartile. And that is the values for without weight tracking system. Now let's go to with tracking system. Let's do it again. The mean is average, whole column B. Next is the median, the word median, equal median, whole column B. For the mode, equal mode, you can use singular or simply mode, close parenthesis, or let's singular. Singular, it means it will just select one mode. And true enough, we only have 12. 12 is the repeating number, so that's only our mode. So let's go to, there's no other mode than 12. Let's go to range. Again, the maximum of column B. We subtract that with the minimum of the same column, column B. Close parenthesis. We have to write the close parenthesis there. Variance, var.s for a sample. So normally we're dealing with samples when it comes to the statistics. stdev.s for sample, p for population, but we're using sample. Coefficient of variation is the standard deviation divided by the mean. The 85th percentile is equal the word percentile.xe, the array B, and comma 0.85 for the 85th percentile. For quartile, equal the word quartile, and then select all the array, and 1 for quartile 1. Let's do this again for quartile 2, word quartile, all array B, comma 2, quartile 3, array B, comma 3, and lastly, the interquartile range, or the IQR, that is the difference between the third quartile minus the first quartile. And that's it. If you want your values to look consistent, so you can highlight the values that you want to lessen or increase the decimal places. In the upper part here, you can lessen or increase it. Let's lessen it to 2 decimal places. So that would look consistent. But actually, there's a shortcut here if your Excel has a data analysis. So go to Home, Data. Here in Data, select Data Analysis. In Data Analysis, select Descriptive Statistics. And then click OK. Select the column, the whole ones that you want to compute, all of this. And then they are separated by columns. So column A and column B. They're not by rows but by columns. Select label because we have names or label on the top. And then the output range is where you want your data to be. So I will select it here in D20. I will write it here. Or maybe here in A13. Maybe here in D20. I'll just write it here in D20. Then click Summary Statistics. So it will give you all the summary. And then, if you're ready, click OK. Now, we have the following data. It's very consistent to our previous solutions. So we have here the mean. That's the same with 29.1. It's also the same with the other value, 17.2. We have median. We can also see it here, the median, the mode. We have the standard deviation, 16, and the variance. Those are equal. So you can always use this shortcut, especially if your Excel has a data analysis toolpack. And then the range, we also have the same values for range. This will also say the maximum, the count, because we have 10 sample. We also see here the skewness, the count, the sum, if you add all of it. So this is a more complete data. So you can use this too. So let's get the descriptive statistics.
Ayan. So, I'll just return my audio. Okay, so as you can see, actually it's, if you have data analysis in your Excel, and we have data analysis in our Excel because we have a premium one from FEU, you can actually use just data analysis and get the descriptive statistics. It will give you all the data that you need and not need. So it's just there. At least it can do it for you, especially if you're talking about like how many, like not just without waiting time, with waiting time, and maybe a lot of another columns. You can just do it in how many clicks only, unlike the manual way of solving mean, median, mode, range in Excel. So yeah, so this is how we solve it. But let's go back to the problem. Now, my first question here is, so we're talking about without waiting time and with wait tracking system, without wait tracking system, and with tracking system. So, isa-summarize ko ulit yung tanong ha. Ang problem talaga dito sa sample na ginamit ko ay ganito. Yung binigay na numbers dito, ito yung waiting time ng mga tao na hindi binigyan ng wait tracking system. Sila yung hindi in-inform na, uy, you have to wait 30 minutes kung pupunta ka sa patient's office. Sila yung hindi informed. Now, this wait tracking system, sila naman yung informed na sila yung informed na may waiting. Like sabihin sa'yo, ay kung pupunta ka ngayon sa physician's office, you will wait for 20 minutes, or you will wait for 30 minutes, or you will wait for 10 minutes. And then supposedly you will adjust your time going to the physician's office. Now, first, sino ang may mataas na waiting time? So normally, if we're talking about mataas na waiting time, we will check the average. So I'll highlight the average. Okay. Sino po yung may mataas na waiting time? Sige, ito na lang yung tanong ko. Sa tingin nyo lang, so these are just hypothesis. Sa tingin nyo, sinong mas effective? With or without tracking system? Tandaan nyo, pag ikaw ay naghintay, kung without tracking system, naghintay ka daw, let's say, on average, maghihintay ka ng 29 minutes before ka matawag ng physician. Ito naman, maghihintay ka with tracking system, maghihintay ka ng mga 17 minutes before ka tawagin ng physician. Sino sa kanila ang mas effective? With or without tracking system? With tracking system. Thank you, Alvi. That's actually very correct. With tracking system. So with the measure of descriptive statistics, the measure of central tendency, we can actually know on the average, sino yung mas may maliit na waiting time. Kasi yun naman talaga yung goal natin eh. Onti lang hintay mo dun sa physician's office. The next one is I want to know kung gaano kalayo yung data sa isa't isa. It's very important that you know how far data is from each other. Kasi kung alam mo kung malapit sila, pwede ka mag-approximate, siguro mga ganitong minutes lang yan. Kasi from our data, normally mga 17, 18, ganun lang naman siya. Or sabihin natin, normally 29, 28. So siguro mga ganun lang, mga 28 minutes maghihintay. So the consistency, how far the data are from each other. Now, to do that, let's use the standard deviation. Now, ang gagamitin kong words ay, sino yung mas malapit sila sa isa't isa na data? Yung less, hindi sila ganun kalayo na values. Malapit lang sa isa't isa, with or without tracking system. Malapit ha. Malapit. When we say malapit, di ba pag ang standard deviation, pag mas mataas yung value, that means mas malayo. Mas malayo sila sa isa't isa. Mas mataas yung error. Yung data na to, siguro ang time na to ay 24, tapos 67, tapos 12, malayo sila sa isa't isa. The lower the value, ibig sabihin, mas consistent yung data. They are near to each other. Like, sabihin natin, 16, 11, gano'n lang yung mga values nila. Without, yes. Thank you, Michael. Thank you, Danica. Yes, with tracking system, very good. This one is mas malapit yung data sa isa't isa. Therefore, mas less yung errors. Less, when I say less, I'll just use the word less here. Less errors. Kasi yung value niya ay malapit sa isa't isa. Ano ba ibig sabihin ng 9.28? On the average, ang layo nila ay 9.28. Yun yung ibig sabihin nun. Kung ito yung data, 11, or sabihin natin 10, on the average, ang layo nila sa isa't isa ay mga ganon. Yan. So yan. Yun yung on the average, yun yung layo nila sa isa't isa. Yun yung ibig sabihin nun. So yeah, that means they're more consistent. Yung values nila ay mas malapit sa isa't isa. Thank you, Michael. Thank you, Danica, for your answers kanina. Okay, so yeah, so that's how we use the descriptive statistics tool in Excel. Now, the next one is what we call outliers. Let's say you ask a question. Like, sabihin natin sa kaklase mo, sabi mo, oy, magkano yung baon mo? Sabi niya, 150 pesos per day. Yung isa naman, ang mga 200 pesos per day. Yung isa naman, 100 pesos per day. Pero may isa kang kaibigan. Pag tinanong mo siya kung magkano yung baon niya, ang sagot niya ay 2,000 pesos per day. Nagsisinungaling ba siya? No. That person is not part of the normal. So we call that person an outlier. So there's a possibility. Like for example, ilan kayo magkakapatid? 3, 5, 6. But there will be cases na sila magkakapatid, mga 20 sila. So hindi naman nagsisinungaling. That's actually real. But they are not common. They are what we call the outliers. Now yun nga lang, pag sinabi mo yan sa professors mo, when you do research, sasabihin mo, ma'am, tinanggal ko yung data na to kasi siya ay outlier. But how do you know? How do you say it? How do you compute it scientifically na outlier nga talaga siya? So dito na papasok yung tinatawag natin na interquartile range. The one that we computed earlier, the quartiles, we use that to get the outlier. And then we use a box plot. This is a box plot where we make a graph of what is allowed. And this is what we call the whiskers. Hanggat dito sa box, allowed, at yung sa whiskers, pwede pa yan. Pero paglampas ka na, outlier na yung considered sa'yo. So sometimes, it depends on the research. Maybe you want to study about the outliers. I think mayroong libro dyan. May librong kay Malcolm Gladwell ba yun? Yung The Outliers. There are studies that their goal is to study the not normal, the outliers. Now, if that is your goal, if you want to know the outliers and then study the outliers, that's a different use of this one. Or you want to take out the outliers so that your data, the one that you have, will represent the actual, the normal values na alam mo. So let's have an example here. So we have here countries and their gross domestic product in US dollars. So we have here Afghanistan, it's 18,000. I think I have a lot of that in the Excel file, but I'll just put it here. We have 1,000 for Angola, and then etc. Now, how to use Excel to get the outliers? So I will use the audio in this video. Just tell me if hindi pa rin siya nag-work out.
So let's check if data has outliers. So to do that, let's compute first for the third quartile. So quartile.xe, the array, comma, the third quartile, so 3. Next, you can solve for this or not, it's your decision. It's quartile 2, so quartile.xe, the array, and 2. Next is quartile 1, or the first quartile, quartile.xe, parentheses, the array 1, and then close parentheses. So we have now the third and the first quartile, because for the IQR, the interquartile range, we will subtract the third minus the first quartile, and we will have that value. Now on the upper part, we will first get the third quartile value. We add it with 1.5 times the first, the interquartile range. So we have that value. The next one, the first quartile, we subtract it naman with 1.5 times the interquartile range. So we have this value. So this is inside the box, or this is what we call the normal values. Beyond these values are actually the outliers. So we can determine outliers if they are beyond this value, more than 4 million and less than negative 2,000. So who are more than 1 million here? Who are more than 4 million pala? 15 million for US, 7 million for China, and Japan. So these are our outliers. But there's a shortcut here. We can use the box and whiskers. So click insert, select box and whiskers in the charts, and then we have this. So this came from our computation of quartiles and interquartile range. This is the interquartile range, and these 3 dots are our outliers as shown in our previous computation. The 15 million, the 7 million of China, and the 5 million of Japan. So this is box and whiskers.
So this is what we call the box plot. It's common. I think ginagamit talaga siya. Tinuturo siya actually sa basic statistics. Now, you can, if you have that subject, you can double check your answers by using the box plot. Makikita natin na may tatlong outlier. Hindi naman sa mali yung values nila. It's more of hindi sila part sa quartile, ang tinatawag na interquartile range. Hindi sila common at yung mga acceptable common. So, hindi pasok sa whiskers. So, sila ay beyond the values of normal. So, we use the outliers. Now, there are studies that they're studying outliers. So, they have a data and then they use the box and whiskers. They take the outliers and then study the outliers. Ano bang common? Ano bang common ng mga outliers na to? Bakit sila mas successful? Ano bang common sa mga outliers na to? Bakit sila outliers? So, we use this in statistics na analysis tool to take the outliers and to study the outliers. Okay, the next topic that we will have is now inferential statistics. Now, inferential statistics, we usually use it to make decisions. Now, we don't describe, it's no longer the descriptive statistics. We have now the infer. So we infer with the one that we've computed. So we have inferential statistics. Now, the first one that I will discuss is what we call correlation. Now, this is very simple. Correlation is evaluating the relationship between two variables and how is one variable related to each other. So the most common is what we call the Pearson's correlation. If you want to know about correlation, we have actually Spearman, point by serial, phi correlation, but the most common one is the Pearson correlation. If you want to know more about the other types of correlation, if that is part of your study, you can check your statistics books. So let's have correlation. So for correlation, we just added their covariance. So covariance talks about the linearity. So the higher the value, the more linear the relationship is. But we can just use correl. Correl in statistics, equal correl, computes for the correlation. So let's say we have this problem. So let's guess muna. Let's guess the result and then let's check the result. So in economic downturn in 2008 to 2009 resulted in a loss of jobs and an increase in delinquent loans for housing. In projecting where the real estate market was headed in the incoming year, economists study the relationship between jobless rate and the percentage of delinquent loans. The expectation was that if the jobless rate continued to increase, there would also be an increase in percent of delinquent loans. The following data shows the jobless rate and the delinquent loan percentage for 27 major real estate markets. So ito yung gusto nilang malaman. Kung joblessness or unemployment, may effect ba yung percent ng unemployment sa isang lugar, like sabihin natin sa Boston, may effect ba yung, may related ba, correlated ba, may relationship ba ang joblessness sa mga delinquent loan, yung hindi binabayaran na loan. So they want to know if the higher the value, the higher the jobless rate, kung mas mataas yung unemployment, mas mataas din daw, yun yung theory natin, try natin, mataas din daw ang delinquent loans. Or maybe, baka, pag mas mataas, higher jobless rate, or what we call jobless rate, mas mababa yung delinquent loans. Possible kaya yan? Or baka wala talaga silang relationship. So, let's guess. Can you chat me dito sa chat box? Kung sa tingin nyo, is there a relationship between jobless rate and delinquent loans? Is there a relationship? Mas unemployed ba? Mas maraming hindi nababayarang loans? Yes? How about the others? Yes, then? Tignan natin. Yes po, yes po. Yes, yes, yes. Okay. Yes, yes. Okay. So, tignan natin if correlated ba talaga siya. And normally in statistics, if you want to know if two are related to each other, we use what we call the correlation. So how do we use correlation in Excel? But I will discuss muna the expected result. I know you can compute We have formulas for that. We have Excel to compute for you. But the result, ano ang implication ng result? So let's check.
Here we want to know if the jobless rate in percent and the delinquent loans in percents are correlated. That means if they have a strong inverse or direct relationship, or maybe no relationship at all. Now to solve that,
we will use equal correl. Correl means correlation. Parentheses, we have the RA1 and select the RA2. And we will have 0.44. And that's here, somewhere here in 0.5. That's actually a weak relationship to no relationship at all. So that means jobless and delinquents are not related. But we can use the box and whiskers again for outliers. Maybe if we take out the outliers, we have two outliers here in the delinquent loans. Let's take that out. Maybe it will have a different result. So let's take out Miami. Let's have another one. That's 11.12. Let's take that out. That's Las Vegas. Let's check again. The correlation is 0.47. Still weak relationship. So by correlation, delinquent loans and jobless rates are not correlated at all.
Yeah. Actually, hindi din siya yung answer. But in this data, I forgot what year this is, but in this data, hindi sila correlated. So that means ang joblessness, hindi siya correlated sa delinquent loans. What could be the reasons? Maybe if you're jobless, if you're in the point na ikaw yung jobless, from the start, hindi ka talaga makakaloan. Ano, nagets niyo ba yung point ko? From the start, hindi ka, kung ito yung person, yung isang person na to, siya ay nasa brink of joblessness, maybe that person is not, will not be authorized to loan. So baka yun yung naisip kong reason. That's why we can say that sadly, they are not correlated. Hindi siya, yung expectation natin and yung reality sa statistics ay hindi nagtugma. Yes, that the answer is weak correlation or no correlation at all. May magandang comment dito. Maybe may ibang source of income kaya nakakabayad sila. Oh, actually, that's true. If you're jobless, that is just a job. Maybe you have other source of income. Maybe you have a rich parents, and then you can still pay for your loans. So, yeah, that could be a case. Yeah, and here in the US, they have EDD. That means if you don't have a job, the government will pay you for a certain number of months until you find a job. Maybe they will give you like 3 to 6 months. They will pay for you a minimum live money, like livelihood money, and then hanggang makahanap ka ng trabaho. So you have to apply for that. So I think since this is a US data, that's actually possible. Yan yung sinabi ni Nino dito, baka may ibang source sila of money. For US, yes, that's actually possible. For the Philippines, maybe it's your turn to look for the values if delinquent loan is related or correlated to joblessness. Ayan. Now, I'll just discuss this further. A quick discussion for this one. Let's say you got a value. So let's just discuss how we compute it. So if you got a value that is, sabihin natin, 0.8. Ibig sabihin, correlated sila, highly correlated. That means they are in direct relationship. That means kung mas mataas yung joblessness, mataas din yung delinquent loans. For a negative value, that means they are inversely correlated. So if you got a negative 0.8, that means they're strong. They're strongly correlated. But the relationship is actually opposite. If the one is higher, the one is lower. So opposite, inverse yung relationship nila. Okay, so we have here a message from our moderator. Hi everyone, feel free to post here your questions or clarification. You may send a direct message to me too. Sabi ni ating moderator, Sir Alvin Cola. So yeah, so we have this discussion for correlation. For data that are qualitative, like for example, female, male, kung correlated ba yung gender sa pay. So mga ganon, we normally use another type of correlation, and that is not the Spearman, the fee and the point bar serial correlation. So if you want to know more about that, you can DM me and I'll send you a tutorial on how to solve it. Okay, so the next one is the topic of the z-test. So for the z-test, dito na papasok yung hypothesis testing. Now, statistical hypothesis testing is a decision-making process for evaluating claims about the population. Now, normally, we use different ways to reject and to accept a null or alternative hypothesis. So we use the z-critical, or sometimes we use the p-value. Normally, if your p-value is less than the alpha, you reject the null hypothesis. Okay, so let's have here an example. A researcher claims that the average cost of men athletic shoes is less than $80. He selects a random samples of 36 pairs of shoes from a catalog and finds the following cost. And those are the values. Is there enough evidence to support the researcher's claim at alpha 0.1, 0.1 or 0.10? This one is what we call the significance level. It says that if nagpass ka beyond that value, that means it's significantly different from the other values. So kaya siya sinasabi talaga. Ang normal alpha is alpha 0.01. That means you only take 1% risk. The default, this is the default. If you use Excel, the default is 0.05. That is the 5%. You are 95% confident with your data. We call that the confidence interval. And you have 5%. Yun yung mga risk na gusto mong i-take. Mga 5% risk, tanggap ko yan. Mga ganyan. Or you can be more forgiving. And this is the 10%. So this is actually a high value. It's kind of forgiving. But if you want to be strict, sometimes they use the alpha 0.001. The default one is this. Okay, you can know more about that in higher statistics. Now, we have here this data. Now, ikukwento ko lang siya ulit. Parang ganito. Kunwari guys, may nag-claim, or sabihin natin, may nagsabi, or may isa talagang document, na ang average cost ng sapatos ay $80. That will be our null hypothesis. Remember, the null hypothesis should always be equal. Kasi when it comes to rejecting and not rejecting the null hypothesis, ang table natin, they only worked in equal. Kaya nga si null hypothesis lang yung nire-reject at yung fail to reject. So siya talaga yung unang tinitignan, yung may equal sign. So this is our null hypothesis. And our alternative hypothesis, in our claim, it should be less than. So this is common if let's say you have a study. Sabihin natin, may isang researcher, sabi niya, ang average tuition fee ng mga estudyante ay 40,000. Tapos sabi mo, hindi yan average na tuition fee ng mga estudyante. Luma na yung data mo. Iba na ngayon sa 2021. Hindi na siya 40,000. So to prove your claim, kumuha ka ng sample of universities and you look at their tuition fees. Tapos, gagawa ka ng null hypothesis. ang null hypothesis mo ay equal ba talaga siya sa 40,000? Ang alternative hypothesis mo ay hindi na siya equal sa 40,000. So of course, depende yan kung sino yung gusto mong manalo. Ang gusto mong manalo, in this case, ang gusto niyang manalo kasi ito yung claim niya na hindi na siya equal. But what if kung baliktad, ang gusto mong manalo ay yung isa, so you just check it. When I say gustong manalo, doesn't mean siya yung mananalo. You have to use statistical tools to know if you will reject or accept the null hypothesis. Now let's, step 2, step 3, step 4, step 5 here are actually the manual way of solving the z-test. But I will use Excel on solving this problem. Okay. You have a population mean. And this is already a standard with a standard population, standard deviation of 19.2. Now you can compute for the variance. It's just a square of the standard deviation. Now, let's say that this is already, we want to claim that this one is already outdated. So we want to know if it's really less than 80 now. So to test that claim, we will first write our null hypothesis and alternative hypothesis. The null hypothesis states that the now and the before, the known population mean, and the now version is equal. They are still equal to 80. But then you want to claim that it's actually less than that. So what you did is you get a sample, a 36 sample of the new data. And we will use z-test to prove if your claim is right or not. So let's use data analysis. So click data here in Excel, data analysis, and select the z-test. So click enter, okay? And then let's select our variable 1. Our variable 1 is a sample that you got. The variable 2 is the dummy. Now, I put a dummy here because we already know the population mean. So we just use a dummy. If you're comparing samples to samples, you can put the sample data here. But since we already know the value, we put a dummy. And then let's write the hypothesized mean difference, and that's 80. We want to know if it's equal or less than 80. The variance is something that we've computed before, so it's this one. And then for variable number 2, let's just put a really small sample because Excel will not compute if we make it just 0. Our level of significance is 0.10. Be careful with this one because the default in Excel is 0.05. For us, it's 0.10. Click label because we have labels here. And then our output range is where we want to show the data. Let's show the data here. And then I will click OK. So we have these values. Now, let's see if we will reject or not reject the mean. So let's draw a normal distribution graph, bell curve. It says here that our one tail, since this is less than, our one tail, we will use one tail test, is 1.28. So that means it's 1.28 here and 1.28 here. Normally, this is negative in this side. Now, our rejection region is this one. If the value is less than this value, we will reject the null hypothesis. Our z is a negative 1.56. It's a negative 1.56. Therefore, 56. 1.56. Therefore, we reject the null hypothesis. And yes, our claim is true. We reject this. Therefore, our claim is true. That is actually the values now, the sample that you got, is less than the known population mean. And that is the answer, the alternative hypothesis. You have Yeah. So that's how we use z-test. Now remember the difference between the z-test and the t-test. Normally z-test is used if you have more than 30 data. Ang t-test, siya ay para sa super onti lang yung data mo, like 30. But actually you can use them in both. Like you can use them in both. You will almost the same have the same. You will almost have the same result. But z-test is more used if you have known more, mas marami kang data compared sa, ang t-test ginagamit siya sa mas less than 30. Pero ginagamit din siya sa more than 30. Mas preferred lang siyang ginamit sa less than 30. Okay, so here we have sample to sample. Normally guys, if you want to compare two, like ito, yung sample na to at yung sample na to, you can put a data here. I just put a dummy because we already have a known population. It's not something that you compute na. It is something that maybe you've already seen in a book, seen in a statistical tool. Sabihin natin, ang normal income ng Pilipino ay ganitong amount, pero gusto mong i-claim na, ay, hindi na siya ganon. Mas iba na yung mean average income ng mga Pilipino sa year 2001 and year 2020, year 2021 and year 2022. So, for those cases, we use a dummy. Now, this is very similar with t-test. Now, I will show you t-test. So, t-test is a statistical test for the mean of a population and is used when the population is normally or approximately normally distributed with a standard deviation that is known. So this is the formula. So ayan, it's either you have greater than 30, you can use this t-test if it's more than 30, but pwede mong gamitin sa less than 30, but dapat sila ay normally distributed. Okay, so let's have this one. This is a very interesting data. Research results suggest a relationship between TV viewing habits of 5 years old children and their future performance in school. For example, Anderson, Houston, Wright, and Collins report that high school students who had regularly watched Sesame Street as children had better grades in high school than their peers who had not watched Sesame Street. Suppose that a researcher intends to examine this phenomenon using the sample of 20 high school students. A researcher first surveys the students' parents to obtain the information on the family's TV viewing habits during the time that the students were 5 years old. Based on the survey result, the researcher selects n is equal to 10 students who has a history of watching Sesame Street, and an n student, n is equal to 10. So 10 students who did not watch the program. The average high school grade is recorded for each student, and the data are as follows. So we have here the null hypothesis. They don't have difference. The alternative hypothesis is they have difference. So ito talaga yung kwento. Tatagalogin ko muna. Ang kwento dito is gusto nilang malaman if may effect yung panonood ng Sesame Street ng estudyante sa grade ng mga estudyante. I think we cannot relate that much to Sesame Street, but we have our own versions here in the Philippines. Di ba may version tayo ng Sesame Street? It's just very simple cartoons, but these cartoons actually teach young children, 5 years old and below, what is A, what is B, how to add simply, how to subtract, etc. Can you tell me what are those Sesame Street-like TV shows that you watch? Kasi iba na tayo ng generation. Kami TV lang yung tinitignan na, di ko alam kung ano yung tawag sa inyo. Yes, siniskwela, totoo. Batibot, yan. Batibot po. Batibot. O nga, no? Batibot, siniskwela. May isa pa, mathinik? Or mali ako? Nakalimutan ko na Cocomelon, pero totoo. Actually, yung pamangkin ko, Matinik, yan, Matinik. So we have that version in the Philippines, right? Yeah, actually, for nakaka-relate ako sa Cocomelon. I have 2 young niece and nephew, and nieces pa, marami pa akong nieces pala. Sila ma-addict sila sa Cocomelon. And I don't want to watch I don't let them watch TV that much. Pero na-realize ko, after reading this studies, na-realize ko na iba kasi yung approach nila sa mga bata. Iba yung paglagay nila sa utak, pag-shoot nila ng information sa utak ng mga bata compared sa pag sinasabi natin. Yes, Superbook, Hiraya Manewari. Yes, napanood ko pa yan. Yeah, those type of a series sa ating TV shows. So, gusto nilang malaman kung may effect ba talaga sa utak ng mga 5 years old. Kung nanonood sila nito nung 5 years old sila, ano kaya yung grade nila pagdating sa high school? So, before tayo mag-solve, anong hula nyo? Is there an effect? Mas tataas ba yung grade nila? Sige. The question doesn't really, hindi pala siya effect. It's more of, may difference ba? Sige, sabihin nyo lang, HO or HA. HO means walang effect, walang difference. Kung nanonood ka man o hindi ka nanood, pare-pareho lang kayo ng average. H1, so I'll just highlight that. H1, may difference. Kung nanood ka at hindi ka nanood, magkaiba talaga yan. There is a difference. What is your, no difference. There is a lot of factors involved. Yeah, that's a really good, hypothesis. How about the others? HO, yes, no difference at all. HO, no difference. Yung iba naman, may difference. Okay, so H1 naman, I think. Yan. So tingnan natin if that is correct. We will check, we will use, meron po kasi may familiarity. Yan, based sa bare data, I think H1. Wow, thank you for your hypothesis. So I'll check using t-test. So how to use t-test when we're comparing data? So this is very useful if, for example, treatment 1, treatment 2. Kung may effect ba yung treatment na to kung may pagkakaiba ba. So ang tinatanong lang kasi talaga ni z-test, kung may pagkakaiba ba sila. May pagkakaiba ba yung treatment 1 at treatment 2? Kung gusto mong malaman kung ano yung maayos na sabon, may pagkakaiba ba ang effect ng mahal na sabon at murang sabon? So we just want to know if they have a difference or they don't have a difference at all. Okay. And medyo strict tayo. Ang ginamit niyang alpha dito is 0.01. So remember, ang alpha natin is 10%, 1%, and 5%. Ito medyo strict siya. 1% lang yung ginamit niyang significance level. To say that they are significantly different, 1% na yung allowed na errors. So let's check using Excel.
Using t-test, we want to know if there is a difference between the high school grades of students or children who watch Sesame Street and those students who did not watch Sesame Street. So let's set the null hypothesis that they have no difference. For those who watch and did not watch, they actually have almost the same grade. And the alternative hypothesis is they are really different, significantly different, for those who watch and did not watch Sesame Street. In t-test, we normally check the null hypothesis. So our goal is to recheck or not recheck the null hypothesis. So first, click data. So we click data here in above, data analysis, and then we will select t-test with 2 samples of unequal variances. So we don't know the variance, so let's say that they have unequal variances. And then we click OK. We select the cells. So first, the watch Sesame Streets and the did not watch the Sesame Street. And then we hypothesize 0 because there's no difference between them. That's our null hypothesis. We check labels because we have labels here in our table. And next is the output range. The output range is where we put our data. And of course, maybe here we'll put it, and of course the alpha. The alpha is 0.05. It could be 0.01. So let's set 0.01. And then we click OK. And we have these values. Now we compare the t-stat with the t-critical two-tailed. Since 4 is greater than the t-critical, Therefore, we reject the null hypothesis if it's greater than that. We can also use the p-value. If it's less than our significance value of 0.01, 0.01, we compare it to our p value, which is 0.00839. And since that is less than our significance level of significance, that is, we reject the null hypothesis. Since we reject the null hypothesis, therefore, using the level of significance of 0.01, our answer will be the alternative hypothesis.
Okay. So that's my microphone, right? Okay. So here,
Using t-test, you want
so let's evaluate
using t-test.
the result. So let's evaluate the result. Kasi parang hindi siya clear dito. First, pwede kang gumamit ng two tools. If you see this, malalaman mo if two-tailed or one-tailed. Or one-tailed or two-tailed. Ang one-tailed kasi, guys, is when ang null hypothesis, nakita nyo to sa z-test, yung greater than less than, normally, ang ginagamit dyan ay mga one-tailed. Pag equal and not equal, yung pinag-uusapan, kasi ibig sabihin, kung may distribution ka, ang tinitignan mo ay yung left at yung right, dito at dito, kasi tinitignan mo lang naman ay equal or not equal. Pag ganyan, two-tailed yung ginagamit. So, again, uulitin ko lang yung explanation dun sa result. First, you will make a normal distribution. And let's look at two-tailed. So we're talking about two-tailed because it's equal and not equal. Now, let's look at the critical. So the critical is 2.8. And on the other side, it's also 2.8. And this will be our rejection region. So magre-reject ka ng hypothesis pag ang nakuha mong value is more than or less than that. I'll put a negative here. Now, ang nakuha natin is t-statistics natin. Again, ang t-statistics natin ay 4. So it's somewhere here. So it's actually clear that we reject the null hypothesis. Now, what if you decide na ang gagamitin mo ay p-value? So normally, ang mga p-value, hindi mo siya kailangan i-drawing para ma-imagine mo. Ang kailangan mo lang is isipin kung less than ba siya. Di ba ang level of significance natin is 0.01. If siya ay less than 0.01, so it's the p-value is dependent on the significance level na sinabi natin kanina. So if it's less than that, you have to reject. So it's actually less, so you have to reject. So you can have two methods to check if you're doing it right, if you got the conclusion right or wrong. You can I normally use this one, but if you want to, this is actually easier, is rely on the p-value. And then return back sa sinet mong significance level. I'm sorry. And our last one. Our last discussion will be ANOVA. Now, this is an extension. So, ang sagot kanina pala, di ba naghulaan tayo, H1, HO, ang sagot is, na-reject natin si HO, hindi siya equal. Ibig sabihin nun, H1. Wait lang, guys. Ang ibig sabihin nun, H1. That means, watching and not watching Sesame Street has an effect on students. So, has an effect on high school. Nanonood sila nung Sesame Streets, nung grade 5, yung 5 years old pa sila, may effect yon pagdating nila sa high school. So, H1 is the answer. So, I encourage parents there, or maybe your younger siblings, na sometimes it's actually healthy to let them watch those type of movies or television shows because they actually have a different effect sa pagtapon ng information. Ginagamit ko talaga yung word ng tapon, no? Kasi iba yung approach nila sa young minds. So, wag lang sobra. Pero they are actually very useful. Like Peppa meron bang, ayan, kay Peppa Pig, I remember my niece, she's really good in speaking English because she's very into Peppa Pig. That's why I like Peppa Pig. So may effect siya sa mga bata. Effect na hindi natin kayang ibigay sa kanila. So the next one is ANOVA. So ANOVA is an extension of a t-test. So this is our last one. ANOVA is an extension of t-test. Now, di ba sa t-test, gusto lang natin malaman kung may effect ba, kung different ba yung nanonood at hindi nanonood ng Sesame Street. But what if you want to know 3 factors? Like tatlo. You want to know if there is a difference between 3 factors. So we use ANOVA. ANOVA doesn't test one mean to less than other, or only whenever they're all equal or at least one is different. So the one-way analysis of variance is used to test the claim that 3 or more population means are equal. So we are now talking about 3. So we have a null hypothesis. Our null hypothesis is still equal. Ang null hypothesis natin ay yung isa, equal lang yan sa isa. Equal lang din yan sa pangatlo. So tandaan natin, a higher extension ng t-test is ANOVA. So tatlo na yung pinag-uusapan natin. Ang alternative hypothesis is at least one of them is not equal. So baka sila ay hindi sila equal. Maybe dalawa sa kanila equal, pero ang isa hindi. So, yun nga lang, ang problem sa ANOVA, inaalam lang niya kung different ba or hindi, or pareho. So, null hypothesis, they are actually equal. All of them are just equal. Doesn't really have an effect. Alternative hypothesis says there is an effect. So they are different. So let's have an example. I think that's clearer if we have an example. So let's say we have here the statistics classroom is divided into 3 rows, the front, the middle, and the back. The instructor noticed that the further the students were from him, the more likely they were to miss class or use an instant messenger used during class. He wanted to see if the students further away did worse on the exam. A random sample of students in each row was taken. The score of those students on the second exam was recorded. So ito yung tanong talaga ng halos lahat ng mga teachers. But guys, my data here is not reliable. I just invented the data here. So hindi talaga siya yung totoong data. Unlike sa mga data na pinakita ko sa inyo kanina, those are real data, but this is something that twitch ko lang. So here, gusto lang natin malaman if may effect ba yung front, kung umupo ka sa front, umupo ka sa middle, or umupo ka sa back. So may effect ba siya sa magiging exam score mo? Kasi the claim here is kung nasa likod ka, or nasa gitna ka, may tendency na pwedeng hindi ka makinig or you can do things na hindi mo naman normally ginagawa. I remember when I was in elementary and high school, we normally shift yung mga nasa back, pupunta sa middle or pupunta sa back para yung learning ay consistent or fair. Yun yung claim nila. So let's see if that is really an effect. So we normally use ANOVA for this one. Now, let's use ANOVA using Excel.
Here we want to know if there is a difference between the grades of the students who are seated at the front, the middle, or the back of the classroom. So we have here grades from the front students, grades of the students who are in the middle, and grades of the students who are seated at the back of the classroom. So to compare them, we first set our null hypothesis. Our null hypothesis is all of them. All of them are equal. What do you mean by that? Their true average or their true mean are equal. That means there is actually no difference in grades. Or the seats doesn't really affect the grades of the students. The HO the HA, or what we call the alternative hypothesis, says that seats as a factor means they are not equal. So seats seated in front, seated in the middle, and seated at the back are actually will result to different grades of students. So we will use ANOVA here, what we call the analysis of variance. Now, how to use it, especially in Excel, we will click data. Here in data, we will use again the data analysis tool. Click the data analysis. And we will have here ANOVA with different factors, single factor, two factor, but we will use the simple one, which is ANOVA single factor. And we will click OK. Then select the whole table. And this table is divided by column. So we will select column. Again, we will select column because they are divided by column. We will click label because we have a label above, front, middle, back. So we will click label here. Alpha, significance, level of significance is stated in the problem. We want an alpha that is 0.05. You can change it into 0.01 or 0.1. It depends on the problem. And then our output range. Our output range is where we want our data, the summarized data, be written or be shown. So it will be here. I will click OK. So our output will be here, and I will click OK. So this is the summary. First, we have count. Count is how many data sets you have. We have 7 for this one, 9 for this one, and 8 data for this one. So 7, 9, 8. We have the sum. Sum, if you add this, you add this, you add all of this, these are the sum. The averages, the individual averages of each column, and the variances of each column. But the most important part is the ANOVA part. The ANOVA part says that we have this sum of squares between groups and within the groups. And we have here the total. This is the degree of freedom. This is 3 minus 1. That's the degree of freedom. And if you add this, minus 1 is the degree of freedom within groups. Now, the most important thing is this 2 and this one. So that's the most important thing.
Ayan. Now, ayan. So, thank you for that. So I'll continue.
Because it will show you if we reject or we accept the null hypothesis. So let's draw it here. What do you mean by this? F critical is where you put the boundary. So this is a drawing of an F curve. Yeah. It says here in the F curve, once you reach the F critical, once you pass the F critical, that means you will reject the null hypothesis. Okay, once you pass 3.4, the F critical, you will reject the null hypothesis. And what is our result? It's actually pass it. Our result is 5.8, and it's somewhere here. So therefore, we will reject the null hypothesis. Therefore, we will reject that all of them are equal. This means they are not equal. The grades of students who are seated in front, in the middle, and the back have different results. That means being seated in a certain position actually affect the grades of students. They are not just similar. Here we want to know if there.
Ayan. So, ang problem lang talaga sa ANOVA is hindi mo malalaman kung saan yung better. You will not know if front is better or back is better or middle is better. Ang sinasabi lang niya is one of them will not be equal. So, may effect. Sinasabi lang niya, may effect yung pag upo sa harap, sa middle at sa back. Pero hindi niya sinasabi kung sino yung sino yung magbibigay ng mas okay. You have to rely on the descriptive, the average, the mean, and the mode to confirm kung sinong mas okay. Or you can use the t-test. So that's it. So thank you so much for listening. All of the videos, the tutorial videos that I have is actually available in this link. I'll give it to you. I'll send it to you later. Now, all the videos, it's here. I can send you the playlist of that link. Now, thank you so much. So if you have any questions, you can email me here at ibernaldez@feu.edu.ph, or you can DM me on my account here. Okay, thank you, and God bless.
Okay, so thank you very much, Ma'am Bernaldez, for that interesting and prolific and of course engaging tutorial session. So we are now opening the floor. Yay. We are now opening the floor for questions or clarifications from our participants. So perhaps I'll start, no? Okay, Ma'am, we have a question. I think it's about cleaning the data. Is it possible to lowercase all apostrophe then capital S?
Yes. I'll show you the. I'll share my screen. I think it's somewhere here. Somewhere here. Normally, if you want to make it like this one, mayroon siyang uppercase pa. So to avoid that, advice ko is use the notation lowercase first,
Okay.
lowercase, all na andito. Tapos, before gamitin yung proper and trim. Proper and trim. So that everything is consistent muna before siya i-lessen yung spaces at i-capitalize yung first form. So, yeah.
Okay.
Thank you.
Thank you, ma'am. For the next question, can you give us, ma'am, other advantages or disadvantages of Excel compared to other analytical or statistical platforms?
I think Excel has limited. I think it cannot carry that much data compared sa other platforms like MATLAB and SPSS. So Excel is a good platform to just analyze data pag onti lang siya. Yung hindi masyadong heavy, baka hindi na gumalaw yung Excel mo kasi hindi niya kayang mag-carry ng malalaking data. But I think Excel will do that soon. Kasi ano naman siya, mas madali naman siyang intindihin compared sa other statistical platforms.
Perhaps, ma'am, if your data involve national records, no? Baka sobrang dami kasi niya.
Okay. Actually, sir, that's true.
Okay. So for the third question, ma'am, example dun sa singular mode, what mode does the Excel show considering the data might be multimodal? Example, you have a data that will give us eventually multi-modes. Kaya lang you choose to only show one mode. So will it be the highest or the lowest value?
From my experience, it will actually show random. Kasi pag nag-enter ka, iba naman yung ibibigay niya. So, ang advice namin is use the multi-mode. So, if you click multi-mode, i-select mo lang lahat kung saan siya pwede maglagay, control, enter. And then, if you fill up niya yung mga blanks na yun.
Okay. So, thank you. So, multi-mode is the safer way to do it. Okay. I think this would be the last. No. We have last two questions. So about if there is a standard type of graph for correlational studies, Kasi sabi rito, most of the correlational studies po kasi use scatter plot instead of box and whiskers. So, and then when to use daw po yung two graphs?
Ang scatter graph is used when you want to know what correlation method. If ang goal mo ay malaman kung may relationship talaga sila, scatter graph is what you use when you want to know kung anong correlation method. Kasi pag nag-scatter graph, pwedeng ang scatter niya ay paganyan, palinear, pwede ang scatter niya ay pa-circular, pwede ang scatter niya ay pa-exponential. So, iba yung correlation tool. Ang normally si Pearson, limited lang siya pag ang scatter graph mo ay palinear. Pag exponential na, ginagamitan na yun ng Spearman correlation. At kung pa-circular, maybe hindi talaga siya for Spearman at Pearson, baka ibang correlation yung kailangan doon. So, ang scatter graph, ginagamit siya for that. Now, ang box plot, ginagamit siya kung feeling mo may outlier, may malaking value or maliit na value na nagdi-distort ng data mo. So, you use box plot so that you will know kung sino yung tatanggalin. Baka sila yung outlier sa data. Yun lang po.
Okay. Thank you, ma'am. Thank you. So, can we expect significant difference between current and previous versions of Excel?
I've used the old one. Hindi siya ganun ka-easy gamitin. Ang new one, siya yung may toolpack. Siya yung may data analysis toolpack. So, punta ka lang dun sa Excel properties, then mag-add in ka ng tools, pipiliin mo yung data analysis. Kasi yung new one, meron siyang toolpack na yun.
I see. So, kailangan nyo po siyang i-access, tama po ba?
So, i-add mo lang siya. Dun ka pupunta sa properties.
Okay. So, I think this would be the last. So, ano daw po ba yung dapat na, tama po ba dapat po muna i-run ang data to see if it is normally distributed before running the data for ANOVA?
For ANOVA, hindi mo kailangan isipin kung, kasi nagko-compare ka ng tatlo, hindi mo kailangan isipin kung normally distributed siya. So, unless gagamitin mo yung t-test. Si ANOVA kasi hindi siya normally distributed. Ang graph niya ay pag pa-skew sa kabila. So, hindi na siya. May isa pa tanong dito, sir. What is the difference between the use of Excel and R analytics? I think R analytics is more powerful kasi yun ay nagko-code ka na talaga. Excel is for like us, like for education, for research, yung simple lang, yung hindi masyadong hardcore. R analytics is for somebody who will be using it in a really higher level way na pwede kang mag-program, pwede mong, yan, may free platform for that. So yun ay for higher level. For our college, for research, I think Excel is good, especially if hindi naman madami. You're welcome. Ayan.
Okay, so thank you very much, Ma'am Isakar, for addressing those inquiries and for providing us, of course, this beneficial presentation. Yay! Thank you. So it was, of course, a pleasure to have you with us today. So to our enthusiastic audience, our speaker won't be able to entertain more inquiries. So because of time constraints, of course. And nevertheless, rest assured that all unaddressed questions will be forwarded to her and sent back to you, to your submitted emails. Okay, so thank you, ma'am. So now to award our certificate of appreciation, let me read the citation. Yay. So Far Eastern University Institute of Arts and Sciences, this certificate of appreciation is awarded to Ms. Isakar P. Bernaldez for her valuable contribution as a speaker during the mathematics webinar series with the theme Data Analysis Using MX Excel. So given this 23rd day of November 2021 at Far Eastern University, Manila, signed by Genesis John G. Borja, our Chair of Mathematics Department. And of course, our Dean of Institute of Arts and Sciences, Dean Rowena Capulong Reyes, PhD. And we would also like to announce our upcoming webinar that may interest you too. So time series forecasting using profit. So our guest speaker is also a colleague in the department, Mr. Frederick S. Helia. And the moderator will be Miss Angelica C. Navarrete. So we now request all our participants to answer the attendance and evaluation forms or the survey form using the link shared in the chat box or shown on the screen. So the request for the certificate of participation can also be found in this link. And as the webinar draws to a close, we'd like to ask our participants to open their respective cameras and wear their best smiles for the picture taking. Sayang we don't have any music background. So thank you for those opening their cameras to participate with our photo op. So can we stop for a while the share screen? Yes, thank you. So we have 6 slides in total, so bear with me. So 1, 2, 3. Next slide. 1, 2, 3. Next slide. 1, 2, 3. Next slide. 1, 2, 3. Second to the last. 1, 2, 3. And the last one. 1, 2, 3. Thank you. So thank you. So as we conclude this webinar, we thank you again for your cooperation and participation. So our appreciation also to the organizers of today's event. So this completes our webinar. So we hope you have learned and enjoyed this presentation. Thank you, everyone.
Thank you.
Thank you.